So these are the main steps, these are the main ideas. I'm going to show you 3 different examples and that's it. As I've done in the past, I'm going to work with an example that's fairly easy. It's just a numerical example. And I'm going to emphasize kind of the factoring first, reducing common factors, and then multiply across the tops and bottoms. Now this is probably not the way you would attack this thing if you were doing it just from what you remember from middle school, but here's what I want to try to re-emphasize with you. When you do these fractions, always factor first. So what I'm going to do is I'm going to put all 4 of these numbers in prime factorization. So 7 is already prime, so I'm going to leave it. But 12 is going to be 2 times 2 times 3. That's 4 times 3 is 12. I already put in the disclaimer. This is probably not how you're going to do these in the long run, but this is what factoring first would look like when we get these algebraic fractions. Then 15 is 3 times 5, and 28 is 4 times 7, and 4 is 2 times 2 times 7. So after I've completely factored, now I can reduce common factors. Common factors must be identical, and the idea behind it is their equivalency of 1. Now these common factors, if you multiply across the tops and the bottoms, here's what you would get. 2 times 2 times 3 times 2 times 2 times 7. And the numerator is 7 times 3 times 5. Do you see any equivalencies of 1 or any common factors that we can reduce? Okay, the 3's can go. These 3's, 3 divided by 3 is 1, so we're reducing the common factor. Are there any other common factors? 7 and 7. So that's an equivalency of 1. We can reduce it. Are there any other common factors? Once you've eliminated all your common factors, you multiply across your tops and across the bottoms, numerator and denominator. So it's just 5 over 2 times 2 is 4, times 2 is 8, times 2 is 16. So when you do these factorizations, I'm going to come back up to the previous step. I can start looking for common factors as long as they come from the numerator and the denominator. Top and bottom cancellation. 7 divided by 7. 3 divided by 3. You know what I mean? I don't have to write this green out first and then do it. I can look for things as long as it's top and bottom. They can come from the same fraction, top and bottom. All right. Now let's come back to here. Middle school math. What were you told to do on these? You can look to simplify. Does 7 go into anything on the bottom? 7 goes into itself once. 7 goes into 28 4 times. Then you can look at your other numbers, 12 and 15. As long as you're comparing top and bottom, is there a number that goes into 12 and 15 evenly? 3. So we divide it by 3, makes this a 4. Divide it by 3 makes that a 5. Then I can re-examine. Is there a 5? Does 5 have any common factors with 4 or 4? That's how we probably would do this if we remember the days of what you were taught in middle school. Okay, so we're going to apply the same strategies to these algebraic fractions, which I have lined up over here. Factor first, reduce common factors, multiply across the tops and bottoms. Factoring is the biggest player that you're going to have to really work on in these problems. And I made them so that they weren't just the simplest factorization patterns available to you. So you look at each of these, numerators and denominators. 9x cubed, it's a monomial. Monomials don't factor. That's it. 4x squared plus 20x. What's in here? A 4 and an x for a monomial factor. So our first factorization strategy is to factor out monomials. If you pull out a 4x, what is left out of the 4x squared plus 20x? Just an x plus a 5. Completely factored, we're going to use that as our factorization. Now we look at the numerator. Both numerators and denominators need to be factored. Any monomial or common factor out of those 3? Nope. There's a 1 here. That's a buster. You can't do it if there's a 1 there. You're trying to find numbers. And there isn't an x in every term, so we're going to go straight to trinomial. Factors into 2 binomials. The x squared is a guarantee of x times x. What does this plus sign mean? They got to have the same sign. Let me sneak a peek in here. They both better be positive. And the factors of 20 that add up to 9 are 4 and 5. So that factors. Then you look at the denominator down here. It's 36x. This again is a monomial. Monomials won't factor. So our factorization is done. Now we're going to see if we can find any common factors that can be reduced. It has to come from top and bottom. So is there a top and bottom factor that's identical? So the x plus 5 can be reduced. Are there any other common factors? Okay, now this is the one that kind of snuck up us the other day. If you need to, you can write this monomial. 9x cubed is 9 times x times x times x. Does that help at all? I can take this x and cancel out with one of those x's. Those are common factors. That's an x divided by x. That's an equivalency of 1. How about this x down here? That's an x and another x that are over each other. So we can get rid of this x and this x because they reduce to an equivalency of 1. Don't forget to look for numbers. Are there any numbers that will reduce? 9 and 4? No, but 9 and 36. How many times does 9 go into itself? 1. How many times 9 go into 36? 4. Okay, now I got to see what survived all this. What's the only thing that survived? In the tops, what are the things? An x and, so we're going to write down x times x plus 4 over 4 times 4, which is 16. Okay, now with these multiplication ones, you do want to multiply your denominators out. Addition, subtraction, you were not required to do anything with those, but that's your rules on multiplication, division. Multiply the tops and bottoms. Got it? How many do you remember on your handout that I gave you, you had here's the exact problem, 2x squared over 5x, and you had deduct points on it. I thought I'd give you that worksheet back. And this is what a lot of you gave me as your final answer. Was this completely simplified yet? What should we be pulling out of here that it has an equivalency of 1 yet? Yes. So most of the time, you can rewrite it as 2 times x all over 5 times x. And then you might recognize them. We typically start graduating from that idea and just saying, if I've got an x squared over an x, I can get rid of one of those with one of those. 2x over 5. One more example, then I'll cut you loose on these. And you can ask individual questions after that. Whenever we're working with fractions, what has been the theme? What's always the first step? It's going to be factoring. So let's go ahead and take that numerator in the first position. Any monomial factors? 3. 3 goes into 3 and into 27, so get it out of there. You factor out your 3. If you factor out the 3, what are you left with as your binomial? X squared minus 9. Don't give up on those. After you factor out your monomial, re-examine. Take a look at this binomial sitting in here. Does that factor again? Yep, that's the difference of 2 perfect squares. So it's going to be 3 times x plus 3, x minus 3. Okay, so now we have that one done. Go to the bottom. 4x squared plus 28x plus 48. Is there a monomial, a number that goes into all of them that we can factor out? 4. So we're going to pull out that 4. 4 parentheses. X squared plus 7x plus 12. When you factor it out, you're dividing by 4. Don't give up on this trinomial. If you factor out your binomial, this trinomial could factor again. So you got to test it. Leave your 4 out there. It's part of it. Trinomials, if factorable, will go into 2 binomials. X and x, signs are the same, both positive. Factors of 12 to give you a 7, 4 and 3. Okay, so we just did the first fraction. Tons of factoring here. Numerator, in the second fraction, what is your monomial factor? So factor out an 8. You have x plus 4. Does x plus 4 factor again? No, it's not the difference of 2 perfect squares. If it's not the difference of 2 perfect squares, it won't factor again. So all you got to do is test that. Then go down to your binomial. Binomial? 6. We're going to take out a 6. X squared minus 5x plus 6. Try this one again. Does this trinomial factor again? So we at least got to give it a shot. X squared must be x and x. Signs have to be the same. They both better be negative. Are there factors of 6 that will give you a 5 for an outside-inside? 2 and 3. Okay, so here's the things that we have left to work with. Just circle them in red. There's our numerator, numerator, denominator, denominator. The way these are set up, we call them contrived problems. We contrive them so that you can practice the factoring and the simplifying. Are there some things here that we can reduce? Okay, the x plus 4 comes from the denominator and the numerator. You can x it out. X plus 3, numerator and denominator. X minus 3's. Okay. We've got a 6 and a 3. What goes into 6 and 3? 3. That makes this a 2. 8 and the 4. The 8 and the 4 reduce. The 8 becomes a 2. 4 becomes a 1. Are there any other? The 2 and the 2. This 2 and this 2 reduce. Cancel. Holy buckets. What's left in the numerator? Everything got canceled out, so what is that? 1, because all these, really we should be putting 1s on all these, but a lot of times they don't because there's a lot of redundancy. So what's left is a 1 on the numerator. All of these are ones that we canceled out, but the only thing that didn't become a 1, whoops, is I lost track of it myself. It's this thing right there. It's the only thing that didn't get reduced. X minus 2. You should expect to find a lot of common factors here, things that are identical. All right, that's my story. That's what I think we need to do. Factor first, reduce common factors, multiply across. Simpler than the others. So.